How's it going, everybody? So today we're going to be dividing and multiplying rational expressions. And so what we're going to go ahead and do is talk about the various properties and then also talk about a couple examples that kind of illustrate those properties. So let's start off with multiplication. So the property for the multiplication, okay, says that if you have an A over B, so basically any fraction, times another fraction, say C over D, multiplying those two together would be AC over BD, meaning you multiply across, okay? That's the intentions of what that property is trying to communicate. So if we were to actually see that in an example, say you're given something like 5x squared over 2xy squared times 6xy cubed over 10y. Picture this whole piece as the A, picture this whole piece as B, and so on, okay? Because sometimes people think A is like an individual thing, like it had to be the 5 is the A, but think of A as the 5x squared, okay? And hopefully that'll make more sense of the property itself. Now, when we multiply across, we multiply things that are like each other. Like, so the constants are like terms. 5 times 6, that's 30. The x's are like terms in the sense that, you know, they're x's. That's kind of what we're shooting for when we say the like terms. Like, you know, they are all the same letter. We don't want to be mixing x and y and somehow multiplying, getting something like a z. Okay, so x squared times x, that's going to be x cubed. Now, you'll notice the y didn't have anybody to multiply by, so you just kind of bring it along. Now let's go to the denominator. 2 times 10, that's going to be 20. X doesn't have anything, but y squared does, so y squared times y is y cubed. Remember, when you're multiplying variables together, you're adding those exponents, okay? Now, let's go ahead and simplify this. Something you need to understand when simplifying, if you're simplifying variables, what you got to understand is that it's always the top minus the bottom, okay? And better yet, let me start off with a different example. Let me do the other way first. So 4 minus 3 would give me 1, right? So that would be x to the 1 power or just x. Now I know that saying that out loud still may be confusing, and so giving actual, you know, a better visual might help. So technically what I did in my head is I had x to the 4th written out, and then I had x to the 3rd written out, okay? Now the idea is that they will simplify, and if there's an x on top and an x on bottom, they divide out to 1, or some people like saying cancel, right? Leaving you with just your lone x, so this all equals x, okay? So that's the idea behind it. Now, what happens if it's reversed though? Because we always said it was top minus the bottom. So if I had x to the 3rd over x to the 4th, then that would be 1 over x, okay? Now, if you did 3 minus 4, that would be x to the negative 1. And remember, if you have something to the negative power, then bringing it down to the denominator or numerator, depending on where its current location is, will revert it back to being positive, okay? So that means the same thing. But if you would like to see the visual once again, I don't mind doing that for sure. So you have yourself a x, 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 4 more times. These will go ahead and simplify, leaving you with your lone x on the bottom, so 1 over x. Now, I encourage you to get used to the idea of doing top minus bottom, subtracting. Because if you get to a point where I say something like x to the 50, you know, 50th power over x to the, 37, I'm sure you don't want to write 50 x's and 37 x's. You're just going to want to write, what's 50 minus 37? Well, that would be x to the 13th power, okay? And so just try to get good with, subtracting versus writing it all out. It will definitely save you in the long run. So back to our original example over here, we have ourselves a 30 over 20. That piece of the fraction will simplify to 3 over 2. And then the x cubed over x, that'll give us an x squared because 3 minus 1 is 2, so x squared. And then y cubed minus y cubed, right? So 3 minus 3, that's 0. So they go ahead and they simplify out to 1, or they cancel each other entirely. So then you're left with just this as your answer now. And so that's what we're looking for, is not only are we going to multiply, but we are going to simplify. So if you were to look at an additional example of this, you'd have 8x cubed times y over 2xy squared times 7x to the 4th y cubed over 4y. I'll go a little bit faster through this. So 8 times 7 is 56. X cubed times x to the 4th. Remember, we're adding those exponents, so that's 3 plus 4, that's 7. Now there's y times y cubed, so 1 plus 3 is 4. Then on bottom, 2 times 4 is 8. X, nothing, so bring it along. Y squared times y is y cubed. And now we start to simplify. Well, 56 over 8, that's going to be 7 over 1, right? Because 56 is divisible by 8. 8 is divisible by 8. So you'd have your 7 over 1. Now, x to the 7th power minus the 1 on the bottom, right? Because there's an x there. That's 7 minus 1. That's going to be 6. So x to the 6th. 4 minus 3 for the y's. That's going to be just a y because that's 1. Now, you'll notice there's nothing left on the denominator but the 1. So we can simply simplify our answer further to just that right there. Okay. Now, the idea here is we are going to not only be multiplying just pure variables together, but we also need to understand mainly how to interact with, things that are quadratics or things that we can factor. So say I gave you something like this, 3x squared minus 3x over x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. Now this is going to come in handy, especially when we start getting to the point where we add and subtract rational functions. So this is a good starting place. Now, when you start performing these, I know that in the first 2 examples, we went ahead and we talked about how we need to, multiply then simplify. However, in this scenario, we're going to flip that on its head, and we're going to first try to simplify and then multiply. So my objective is I'm going to take my 3x squared, okay, and I'm going to see what could I factor it down to. And the thing is, I can see that they both share a 3x in common, and so I can leave myself with an x minus 1 on the inside of that factor. I also see that this right here, the x squared plus 4x, that piece of information could be, you could use the AC method on. So I could have x squared plus 4x minus 5. That could break up into my 5x and then minus x, because the negative 5, I could do negative 1 times positive 5. That would give me negative 5. But 5 plus negative 1 gives me positive 4, which is the b value. So then I've got x and then x plus 5. X plus 5, and then my negative 1. Now, these factors are what are going to replace the denominator right now. So I've got x plus 5, x minus 1, and there we go. Now, I'm going to do this again for the other fraction, and so I've got myself a x squared plus x minus 20. I could do the AC method here, and that would be a plus 5x minus 4x, there we go, because 5 times negative 4 is negative 20, but then 5 plus negative 4 is a positive 1, so that works out well. And so we have this right here again, x plus 5, and then my minus 4, okay? So that's going to replace the numerator here. And then the 3x in the denominator there, you can't factor that any further, so there you go. Now we're going to try to simplify. Now remember how we tried to simplify top and bottom with the first 2 examples with the x's and the y's. So the idea is if there was an x on top and an x on the bottom, that was, grounds for eliminating or simplifying or canceling, right? Same thing with these factors. So you'll notice this 3x, okay, is on top and on bottom, and so those will go ahead and simplify. They'll cancel. The x plus 5s, they're on top and on bottom. They will cancel. The x minus 1s are on top and on bottom, will cancel. And the only thing left is this x minus 4. And that actually is the answer. Okay, so that's why we go ahead and simplify before we multiply, because you could multiply and then simplify, but you would be in a world of hurt, because it just, simplifying those very massive polynomials would get quite confusing. So let's take a look at an additional example here. So say I have my x plus 2 over x cubed minus 27 times x squared plus 3x plus 9. If you ever encounter a, quadratic that's floating or doesn't look like he is a fraction, put him over 1, and then that will allow you to go ahead and see, okay, now I'm working with this type of fraction. Now proceed with the same, normal process. Let's simplify. The x plus 2, you can't do anything to that, so we'll go ahead and just write him in. The x cubed minus 27, we can. That is the difference of cubes, okay? So we could do cube root of x cubed and then the cube root of 27. And so that would be x, and then that would be 3. And so the formula says we have a minus b, so we'd have x minus 3. And then we'd have x squared plus 3x plus 9, okay? And that's the other part of the formula. Now, you'll notice we typically, in the last problem, we looked at this and said, all right, let's try to do the AC method on this. But I would encourage you not to, because we just, did the difference of two cubes, and we're able to create a polynomial on top and bottom that are the same. So let's not go ahead and factor them. Let's go ahead and just simplify them. And so we have our x squared plus 3x plus 9 over 1. These would simplify, leaving you with x plus 2 over x minus 3. And yeah, there is a 1 right here, but the 1 doesn't do anything mathematically for the problem because you're just multiplying by 1. So you just leave it off, okay? And so there you go. That right there is how we are going to be multiplying rational expressions together. So now let's go ahead and talk about the division of rational functions. So the division of rational functions is honestly the exact same as the multiplication. However, you just have to understand one little thing. The property for it is if you have a over b times c over d, then that's going to equal AD over BC. A lot of people get confused by this and think, did you cross multiply? Truth is, what we did is we had our A over B, but what we do is, and that's the division symbol right there is what that should be. We flip C over D to now D over C. And that's when we multiply across and get the AD over the BC. So it's a matter of flipping and then multiplying, okay? So here is an example. So say we have x squared minus 25 over x squared plus 7x plus 12 divided by x squared plus 2x minus 15 over x squared minus 16. Alrighty, so the idea behind this, ladies and gentlemen, is we're going to first flip the second rational, so that way we can effectively multiply both of these rationals together. Boom. There we go. So the denominator goes to the top, numerator goes to the bottom, and now you are set, okay? Now, the idea here is that we need to now factor these and then see what simplifies. Now, I'm going to factor the x squared minus 25 and the x squared minus 16 a little differently, because that's the difference of two squares. Remember that formula is a squared minus b squared is equal to your a plus b, a minus b. Now, of course, to get the values of a and b, you have to take the square root. So the square root of x squared is x. Square root of 25 is a 5. So then I've got x plus 5, x minus 5. Same thing with the x squared minus 16. It too is the difference of squares, and so you've got yourself an x and then plus 4 and then minus 4, because the square root of 16 is 4. Now if you did the AC method on the denominator, you would go ahead and end up with x plus 3, x plus 4, and then the AC method for the second denominator would be x, and that looks like a 5, and then x minus a 3. And then there you go. Now, of course, looking at this right here, we see what's going to simplify, and in this case right here, the plus 5s are going to simplify, the 4s are going to simplify, and everything else will stay put because there's not one on top and on bottom. So then we got x minus 5, x minus 4, and then you've got x plus 3, x minus 3. And that right there, guys, is division, okay? It's basically, all you gotta do is flip that second rational, and then it's multiplication again, okay? So just make sure as long as you flip and then you multiply, then you are set, and it's just like the other examples we did at the beginning of this video. So with that being said, guys, good job. Let me know if you have any questions, and I'll see you guys tomorrow. Alrighty, bye.